Hello everyone. Logistic regression is a method for classifying the data in machine learning. Logistic regression is generally used when we have to classify the data into two or more classes. One is binary and the other is multi-class logistic regression. As the name suggests, the binary class has two classes, that is either yes or no, true or false, cat or dog, 0, 1, etc. In multi-class classification, there are more than two classes to classify, such as windy, sunny, rainy. So let us understand that how is logistic regression different from linear regression and why does it come under the category of classification? So linear regression is used to generate continuous values like the price or the weather, income, or population. In logistic regression, we generally compute the probability which lies between the interval 0 and 1, inclusive of both. Then, probability can be used to classify the data. For example, if the computed probability comes out to be greater than 0.5, then the data can belong to class A. Otherwise, if the probability is below or equal to 0.5, then the data can belong to class B. Now, let us look at the graph of linear regression as shown here. The graph is a straight line passing through some points since we always avoid underfitting and overfitting of curves. Now, let us look at the graph of logistic regression. The graph is a curved line instead of a straight line, which is unlike the linear regression. So why is the curve of logistic regression straight, as you can see over here, when we apply the thresholds, whereas in case of in the case of linear regression, it is straight when we apply threshold, whereas in case of logistic regression, it is a S type of curve. So the hypothesis of linear regression is that h of x is equal to theta 0 plus theta 1 x. This is something that we had even discussed during the regression module, and in the same playlist you can even find the videos explaining linear regression. If we say that linear regression can be applied as classification model, then we would have to apply thresholds for the same. Let's say y hat be the label of the class. Now, if our h value is 0, or if our h value is less than 0.5, then our y hat value will be 0. And if our h value will be greater than or equal to 0.5, then our y hat value will be 1. So 0.5 is any random threshold value that I have defined over here. Then the graph that you will see looks like this. It is a pure graphical representation. Now, there is one thing that you must notice over here, that every value greater than 0. Suppose it is the value of h is 1000 or some value of for some value of x, it can be labeled as 1. Even if the value of h is 1 for any value of x, it will still be labeled 1. So there is no difference between the value of 1 and 1000, as both are classified as 1, right? So can we accept this solution? Well, no. For these reasons, data scientists do not prefer to use linear regression for classification purposes. So it will be better if we have a smoother curve instead of the previous graphical representation that we had. And that is why we come up with logistic regression, and that is why we have a S type of curve in logistic regression. So logistic regression is a S-shaped curve that can take any real valued number and map it into a value between 0 and 1 inclusive. So in order to map predicted values to probabilities, we use the sigmoid function. The function maps real value into another value between 0 and 1. In machine learning, we use Sigmoid to map predictions to probability. Thus, the hypothesis of logistic regression becomes as h theta of x is equal to 1 divided by 1 plus e power and the whole beta plus beta 1 x and the negative of this. Also, I want you to note the behavior of the sigmoid function. When theta transpose x becomes very bigger than the value of the sigmoid becomes to 1. When theta transpose x becomes very small, the value of the sigmoid becomes equal to 0. Now, as linear regression has the gradient and has the gradient at the cost function, similarly we do have in the logistic regression also. So we learned about cost function j of theta in linear regression. The cost function represents optimization objective. That is, we create the cost function and minimize it so that we can develop an accurate model with minimum error. So as to recall, our cost function has been stated over here, just above on the slide. Now, if we try to use the cost function of the linear regression in logistic regression, then it would be of no use, and it would end up being non-convex function. So in case of linear regression, it was a convex function where it had just one global minimum. But here, in the case of logistic regression, it will be a non-convex function with many local minimums, in which it would be very difficult to minimize the cost value and find the global minimum, as shown in the figure over here. So for the logistic regression, our cost function can be defined as given in the above of the slide, which is minus log of h theta of x if y is equal to 1 and minus log of 1 minus h theta of x if y is equal to 0. Now, the above two functions can be compressed into a single function by joining, and the graphs for these functions have been shown over here. Now, let us move forward to the coding part. We'll be installing our necessary libraries. So, pandas is for taking the CSV file. We don't need this cbond. Thereafter, we are importing our scikit-learn library for training test split. Then we'll be using logistic regression. Thereafter, we have the confusion matrix, classification report, accuracy score as a metrics. Now let us import our data and see how our data looks like. So our data revolves around heart diseases, and this is how these are the different columns, as you can see over here, which are used to see that what are the probability of the 10-year. This is coronary heart disease. So this is something that we need to find out. And these are the different factors representing it. Now we'll do a little bit of data exploration. Our data is the shape with rows of this amount and columns of 16. Now let us describe our data and see. Now under describe method, we can see that what are the counts in male, what is the mean value, standard deviation, what is the minimum value that we are getting, 25%. All the 5 pointers are covered over here. Now, as you can see, under the case of male, it is represented as 1 and 0. Similar case of current smoker, 0 for no, 1 for yes. That is how. So we'll see that if there are any null values over here, then yes, we are able to see that under the columns of education, then cigars per day, BPM meds, then total cholesterol, BMI, heart rate, and glucose, all of these values do have null values. Now, if we want to move further and do any kind of computation, we don't want these null values. Then thereafter for that, what do? We replace the null values with some values. So as we see that education has some null values, we replace the null values with one In case of cigars per day, we replace it with 0. In case of BPM meds, we replace with 0. In case of total cholesterol, we replace it with the mean value, and the mean value is this. Same for BMI, same for glucose, and same for heart rate. Now, as you can see over here, this column should actually be named gender, but it has been named as male. And that is why we'll be replacing the name of the column from male to gender. Now, this is how our column looks like, and we have even rectified the null values. Now we are good to perform the logistic regression. So what do is that we drop in our x values, we drop the 10-year coronary heart disease column, and that is something that we keep as the target value. There, after doing this, we split our data into train and test values, and this is how we have splitted our data. 25% is to 75%. Thereafter, we are calling the logistic function. We are keeping the maximum iteration of this much. Now, if we get optimal value, or if the values of the parameters are repeated over a lot of iterations, then it is not necessary that it will go up to 20,000 iterations. Thereafter, we'll be fitting our train and X train and Y train data. This will take a while because it is quite long iteration that we are doing. Meanwhile, we'll just see what is the documentation for the same. So documentation here is all what logistic regression is, the different parameters for logistic regression that we have, the attributes, everything can be seen over here. Now, this is the shortcut method of seeing the documentation, else you can even go to their official documentation site. After performing this, we want to see that how well the model performs on the trained data itself. And that is how we use the score method. And it is performing to 85%. And seeing how big the data is, it is performing okayish good. Thereafter, we'll be seeing that how well does it perform on the unseen data. So we found out the prediction. Thereafter, we are comparing the values of prediction and y-test, and then we are finding the precision and recall, and thereafter the confusion matrix. So this is what the result comes down to be. This was all for logistic regression. Thank you.